So in this video I want to show you some algebra that you maybe haven't done much of in an algebra or a pre-calculus course that you will find a need to do off and on throughout a calculus course, because typically in a calculus course you're not using your calculator the majority of the time. And so in this equation right here, what we're going to try to do is we're going to try to solve it without a calculator. Now if a calculator was in play and you had a calculator that could graph, the easiest thing to do would be to graph y equals x e to the negative 2x plus 2e to the negative 2x. So basically graph the left side of the equation and then figure out when that equation is equal to 0. So find the zeros of that function. Calculators in play, that's definitely the easiest thing to do. But this is not that difficult to solve without a calculator either. Anytime you're in a situation like this and the calculator's not in play, what you're going to want to try to do more often than not is try to solve by factoring. Okay, so you guys have solved equations like this by factoring. X squared minus 4 is equal to 0, so you factor this, hopefully recognize, all right, difference of squares, so factor it to x plus 2, x minus 2, and then you have a multiplication problem here, and the answer to that multiplication problem is 0, so you set this equal to 0, and you get negative 2, you set this equal to 0, and you get positive 2. You've solved quadratic equations by factoring. You probably haven't solved too many equations that look like this by factoring, but if you're trying to factor this, check out what each piece has on it in e to the negative 2x. So if you factor that out as if it were a common factor, and it is a common factor of those two terms, it's just not something that we're used to calling a common factor. Take out that e to the negative 2x, remove it from this piece, and you're left with an x. Remove it from the second term, and you're left with a plus 2. So what you've basically just done is you've taken an addition problem to the left of the equal sign, you've created a multiplication problem to the left of the equal sign. The answer to the multiplication problem is 0. You know that either this first factor is 0 or the second factor is 0. So if you set each factor to 0, kind of like we said to do over here, and then solved each piece, you're going to have your solutions. So we'll solve this one first. You just have to subtract 2 from each side, so you get x equals negative 2. So there's one of our solutions. This solution is going to be a little bit more troublesome because what we're going to have to do is we're going to have to undo this natural exponential. And so if we take the natural log of each side, what you need to recognize here is that the natural log function is actually undefined at 0. If you think about the graph of the natural log of x, the natural log of x looks like this. There's no point on this graph of y equals natural log of x where x is allowed to equal 0, right? X would equal 0 on the y-axis. This graph never touches the y-axis. So although we have to consider it, this half of the problem doesn't pick up an additional solution. So this particular equation has one solution, and that one solution is x equals negative 2. There's one more that I want to solve with a similar approach. We want to solve this without a calculator. Again, if a calculator was in play, graph y equals all of this stuff. Figure out when that is equal to 0, and you've got your solutions. But if you don't have a calculator in play, take out the GCF. So the GCF here would be natural log of x. So I remove that from the first term, and I'm going to be left with an x squared. I remove it from the second term, and I'm going to be left with a minus 9. I do have a multiplication problem now that has an answer of 0 when I take the product, but you hopefully recognize that what's in here will factor a little bit more. So factor x squared minus 9 as a difference of squares. You'll get x plus 3. You'll get x minus 3. So what you have is you now have 3 pieces of a multiplication problem. You know the answer to that multiplication, the answer to that product is 0. So set each piece of the product equal to 0. So set natural log of x equal to 0, set the second factor equal to 0, and then set the last factor equal to 0. Solve these 3 simple equations. I think you probably agree that these are the easier two, so if we solve both of those, subtract 3, you get x equals negative 3. Add 3, you get x equals positive 3. And then over here, if you're going to get the x out of that natural log function, you're going to have to exponentiate on each side. So when you exponentiate over here, the exponential and the natural log basically cancel with each other. And on the other side, you're left with e to the 0. Well, anything to the 0 power is 1. So this particular equation has 3 solutions. We found those solutions without the use of a calculator at all. So again, it's something that you know. It's solving by factoring, but it's a little bit different because some of the factors are transcendental functions. They're not algebraic, in other words.